Hey everyone, welcome back to the channel. So friends, in this particular video, we'll be solving this particular question, that is range sum of binary search tree. So friends, let's understand the question first. So question, in this particular question, we are given this binary search tree and we are also given two integers, low and high. So we have to find all those nodes that lie in this range, which are basically greater than or equal to 7 and less than and equal to 15. Okay, and then we have to do their sum. Cool. So let's suppose in this particular BST, 7, 10 and 15 are the nodes that lie in between this range. So 7 plus 10 plus 15 equals 32. So this is the question. It is basically easy level. And so friends, before solving the question, let's understand the recursion call stack. So friends, as we know, first the function call will be made for 10. Cool. So as it will be made for 10, what will happen? First it will check for 10. Basically, if it is lying in the range of low and high or not. If it is greater than or equal to 7 and less than or equal to 15 or not. So 10 is greater than 7 and less than 15. So what will happen is, let's take a sum pointer as 0, and what will happen, we will update the sum as sum plus 10. So sum will become 10 over here. Now what will happen is, now it will make a call for its left child, that is 5. Let's see. Now friends, what will happen, as we know, it is a recursion call. Now once again 5 will go, once again the recursion call will work, and what will happen, first once again it will check basically 5 is null or not. So 5 is not null. So after that what will happen, as it is a pre-order traversal, so it will check that if 5 is also lying between 7 or 15 or not. So 5 is not lying between 7 and 15. So sum will remain unchanged, that is 10. And now 5 will be making a call for its left child, that is 3. Now for 3 also sum will remain unchanged. Okay, and now 3 will again make call for its left and right child, and its left child is null and its left right child is also null. So what will happen, a call will be made for null. Now it will check if root is null or not, and root is null over here, so it will return simple null. It will return back to this 3. Similarly, now the 3 will make a call for its right child, that is also null, so it will also return back to 3. So friends, now the recursion call stack for 3 is complete. Okay, now what will happen, now this 5, now the call will come back to 5 again, and now the 5 will check that the left portion is complete. Now the right portion needs to be executed, and now it will make a call for 7. And similarly friends, now again 7 has this as null and null. So what will happen, first it will check that the 7 is in between this range or not. Yes, it is greater than and equal to 7. So what will happen, sum will be updated as 17, and now the call will be made to null and null. Cool. And similarly friends, this execution of 7 is complete, and hence the execution of left and right child for 5 is complete, hence the 5 is also complete. Now friends, the 10 has successfully completed its left side execution. Now it will be completing its right side execution. Now it will be making a call for 15. Friends, now what will happen, sum will get updated once more, because 15 is less than and equal to, basically equal to 15, this high value. Now 17 plus 15 is 32. And now what will happen, 15 the recursion call was made once again, it checked it is not null, so that's why we computed this. Then now its left is null, so basically what will happen, null call will made, and basically it will be returned back. Now the right call will made, and right call will also basically right call is for 18. Now what will happen friends, again it will check for its null, basically again it will check if it is null or not. It is not null, then it will compute it, but as we know that 18 is not in between this range, so sum will remain unchanged, that is 32. And then 18 also will go for its left and right, that is left and right child, and both of them are nothing but null. Hence, this 18 is also executed successfully, and this 15 is also executed successfully. And now friends, as we can see, the left and right child of 10 are executed, and hence the entire recursion call stack is finished. So friends, this was the entire recursion call stack, and finally the answer that we got was sum equals 32. Cool. So friends, what we have used is, we have used a simple pre-order traversal over here. So friends, I hope this recursion call stack is clear to you, and now let's move to the code. So friends, I hope you have understood the recursion call stack clearly, and now let's move to the code. So friends, what we have to do, the approach that we are going to use over here is to find the kind of pre-order traversal we will be doing over here. So I have created this find sum that I will be calling over here, find sum, and I will be passing this root and low and high to it. Cool. And friends, one more thing that we are going to do is, let's create a sum variable and assign it to 0, and this find sum will return us the updated sum, or we can do is yeah, cool. Now friends, what we can do, we have this function over here, let's cool, and let's have these values. Now what we can do, first we have to check for the null case, that if root is not there, then what we are going to do, we have to simply return the null. Cool. Now what we can do, we can simply check, we can simply process the root. And how we can do that, if root dot value is less than or equal to low, and if root dot value is if it is greater than equal and less than or equal to high, then what we are going to do is, we are simply going to do sum plus equal root dot val. So over here we have processed the root. Now we have to call for left subtree and the right subtree, like this, command C, command V, and over here what we are going to do, we are going for left subtree, and over here we are going for right subtree. Friends, I have shown this entire call stack in that particular recursion call stack. So don't forget to don't skip that recursion call stack part, okay? And if anything is not clear in that particular recursion call stack, then do ask me in the comment section. And friends, now what will happen is, this particular piece of code will update the sum, okay? And now what we are going to do, we are simply going to return this sum at last. So what we have done, we have simply created this find sum function. In this we are processing the root, and we are first we are going to the left, left, and then we are going to the right. So in this particular way we will be getting our final sum. So let's see if this code runs or not. Just give me a second friends, I think I have made a mistake. We do not need to return find sum, because we are returning nothing from this find sum. We are just calling this particular function and we are just updating our sum. So what we are going to do, we are going to return this sum from this parent function. Cool. Let's submit it also. So friends, as we can see over here, our solution is accepted. So friends, this is it for this particular video, and if you have learned something new, then don't forget to like, share and subscribe to the channel, and we'll be meeting in the next video with another question.